before help.
Okay, guys, we're starting. Great, good. Okay, thanks for being quiet. So again, sorry, I was a little thrown off. So I was looking at the homework I'm assigning on the weekend, and some involves graph, but I don't want to do graph and sine cosine functions today. So I'm actually going to reduce the homework a little bit, which should be good. But we'll just do pages 5, 6, and 7, just on reference angles and just about tricks. So it should be a pretty easy topic. And then next week we'll get into graphing. Anyway, so we talked about drawing a right triangle from an acute angle and standard position in a unit circle. We discovered cosine is x, sine is y, blah, blah, blah. Matthew, good. Yeah, sure, yeah, good. This one definition of other 4 trig functions in terms of x and y. Remember, tangent's y over x, cotangent x over y, cosecant's 1 over y, secant's 1 over x. So we could use those coordinates to evaluate them, right? And then more importantly, there's a specific way to find ratio of 6 trig functions of any angle as a multiple of a special angle by using the idea of a reference angle. So again, what is a reference angle? So reference angle is simply going to be an acute angle between the terminal side and the x-axis. So for example, if I had something like this here, and I call this theta, then this we theta ref. So we know this, okay. And then to find, say, sine of 120, what do we do? Can I move the screen? I'll wait. Okay. So to find sine 120, you draw 120, right? That's not hard. So here's 120. 120 degrees. So the reference angle would have to be 60 degrees, right? Because that's an acute angle formed between the terminal side and the x-axis. So then 60 degrees, we know that, okay, well, let's draw a triangle with 60 degrees in it, right? Right triangle. And where are the ratios again? S, actually that's S root 3. That's S and 2S, right? Generally speaking, we let S be the shortest side, and then S root 3 is the other leg, and then 2S is the hypotenuse. But because we know that we're in the second quadrant, you could just kind of say, okay, well, we know that cosine is going to be negative as well as secant's negative. Cotangent and tangent are both negative. Sine is positive and cosecant's also positive. So the y coordinates are positive, right, in the second quadrant, not x, right? So at this point, it's pretty easy, right? Like you could say, well, sine of 60 degrees is going to be root 3 over 2 because you're doing over h, right? So cosecant of 60 degrees will be 2 over root 3. And then you get the rest, right? Cosine 60 degrees is adjacent hypotenuse, which is 1/2, but negative, right? Negative. Secant 60 degrees, of course, is -2. And then lastly, do you guys know the identity sine over cosine is tangent? You guys remember that? Yeah, because sine is y, cosine is x, so that works, right? So you can just divide the two I just wrote. Tangent 60 degrees will be negative root 3 because I'm dividing those two fractions. And the cotangent is that flipped over, which is going to be -1 over root 3. And I don't care if you rationalize the denominator. You don't have to. I don't care. It doesn't matter. The AP Calculus, I don't care either, so I'm not going to care. So that's one way of thinking of it, right? If you know the special right triangles, have them memorized, make an adjustment for the quadrant by making some of them positive, some negative. Pretty easy, right? Not hard. So again, because of the fact that cosine theta and sine theta are x and y, along the definition of the other 4 trig functions in terms of x and y, we have the following information. So if this is theta, right, and that's x, and that's y, and that is 1, then of course cosine theta has to be x over 1. Sine theta has to be y over 1. Tangent theta has to be y over x, and so forth. Another way you could think of it too is you can call this r. So remember, for the unit circle, what was r again for unit circle? 1, right? But sometimes you're going to be dealing with stuff that's not dealing with a circle with a radius of 1. So sometimes you may want to say x over r, or y over r, and of course that's the y over x. So sometimes we want to think of it like that too. And we're going to see some problems like that in just a second. So don't always think that cosine is always going to be x, or sine is always going to be y. It just depends on what you're given. I mean, yes, if you're evaluating an angle, yes, know your unit circle, use the x coordinate on the unit circle for cosine, the y coordinate on the unit circle for sine, y over x for tangent, and then flip them for cosecant, secant, and cotan. Oh, when the angle lands on the x, y axes, we use the ordered pairs. So the ordered pairs are obviously 0, 1, 1, 0, negative 1, 0, and of course 0, negative 1. Okay. And so, for example, if I'm doing like, say, the sine of, and here we have a circle, right? So say, for example, I'm doing like the sine of 90 degrees. What would I say the sine of 90 degrees would be?
1.
1, right? What if I want to say the tangent of 270 degrees?
Undefined.
You can say undefined, because you can't divide by 0. Or say I wanted the cosecant of negative pi. What would I say about the cosecant of negative pi? Undefined again, totally. Yep. And you could abbreviate as UND period. That's totally fine. So that's also another thing to think about too. So in this case, you can't draw a right triangle for obvious reasons. Like you can't draw a right triangle. But I mean, yeah, sure, it's 90 degree angle, but one of the base angles is not 90, right? Because you won't have enough room for the third angle. So we just use the coordinates for that. Again, shall all be review. You guys are comfortable evaluating sine, cosine, tangent, all cosine, secant, cotan. Okay. So now let's talk about more of the heart of the matter and what you're gonna have for homework for the weekend. Well, I think you guys get it done today. So it is possible to find the 6 trig ratios of any angle, not just special angles. And sometimes what we need to do is we need to draw. So here's an example. So negative 3, 4. So I'm going to draw negative 3, 4. So unit circle doesn't quite apply here because hypotenuse is not going to have a length of 1. So you could draw this if you want. That doesn't really mean anything to us. I mean, sure, that's theta technically. But what I'm going to do is I'm going to draw a right triangle like this. And this is going to be my reference angle. And I'm also going to superimpose it over here. And I'll just call that theta. I don't need to call it theta ref because, we're just taking this trig functions at that angle. And I'm going to call this 4. I'm going to call this negative 3. Why am I calling the horizontal leg negative 3? Exactly, it's pointing to the left, right? If you're pointing up, make it positive. Point down, make the vertical leg negative. For horizontal leg, if you point to the right, make the horizontal leg positive. If you point to the left, make the horizontal leg negative. Will hypotenuse ever be negative? No. It's like a radius, right? What would be the length of this hypotenuse here? 5. And that's totally, was that? No, never. That's okay. Pythagorean theorem, right? That's all that's happening there. If you want to draw a circle, go ahead. What's the radius of that circle? 5 anyway. So it's not quite unit circle because the radius is not 1. So that's a mistake. I had some students that when I taught at level pre-calculus, like they really kind of drove me nuts because I was like, wait, they're not paying attention. But they'd say, oh yeah, cosine is -3. Sorry, sine's 4 and cosine's -3. Not realizing that what is cosine really? Cosine's a ratio of sides, right? Cosine theta is opposite of hypotenuse. Sorry, wow, I can't believe that. Adjacent hypotenuse. I know math. Adjacent hypotenuse. Sorry, it's Friday. Adjacent hypotenuse. So, can the adjacent ever be larger than hypotenuse? No. The hypotenuse is always the biggest side of a right triangle. So how can this fraction would be larger than 1? So it kind of drove me nuts that when I have students tell me that cosine theta because Mr. E said x coordinate, but that's on the unit circle, right? We're not dealing with unit circle. We're dealing with some other coordinates. So, but this should be pretty easy, right? Sine theta. What's sine theta gonna be, guys? 4 or 5. How about cosine theta? Yeah. Yeah, I trust you guys not gonna make that mistake I just described. -4/3. And then you just flip them. -5/4, -5/3, and of course -3/4. Boom, boom, boom. So we're okay? We're good? Cool. Okay, why don't you guys try example 2 on your own? But tell me which quadrant's in before you guys get started. Which quadrant am I going to be in for this one? What are you guys saying? 3. Yeah, because tangent is positive, which means the ratio of y over x is positive. But since sine is negative, cosine has to be negative to maintain that positive value for tangent. So you're totally going to be in the 3rd quadrant. So a little critical thinking there. Just got to realize that's Q3. Label it. What's going to be the length of your vertical leg? -2. What's going to be the length of your hypotenuse? 3. How about the horizontal leg? Perfect. So I'll write it out, see if you guys get the same thing.
Oh, it's just doing it.
Okay, we're okay? We got all those answers?
-2/3, -5/3, /5, flip them, -3/2, -3/5, /5/2.
For A, okay? Good? Okay. All right. Let's look at another example. Okay. So here's yet another one. So what quadrant am I in here now? Q what? Q2 for sure. And actually, I just realized I didn't have to define all the trig functions. I just felt like it. Whatever, it's fine. It's okay, not a big deal. Yeah, bless you. All right, so we're in Q2. So how am I going to label the sides? Where's the so where does the 6 go? And -5 goes. Yeah, and you want to be mindful about that because -6 over 5 is -6 over 5 or 6 over -5, right? Those feel the same. Just think about arithmetic, not worrying about trig. So from a trig perspective, in the way this is positioned, yeah, 6 has to be positive. The 5 has to be negative, right? Because you're doing opposite or adjacent, opposites pointing up, adjacent pointing to left. Hypotenuse is what, guys? Root. Yeah, root 61. Keep it all in exact form. And then instead of doing all 6 trig functions, we'll just do the ones that the instructions ask for. So secant is 1 over cosine. So 1 over cosine theta. Cosine is -5 over root 61. So it's negative root 61 over 5. Sine is 6 over root 61. And again, I do not care about rationalizing the denominator. Not necessary. You can leave radical at the bottom. Totally okay. Okay. I think we're A-okay there. A couple more examples and we'll start homework. So this should be a pretty easy going day today. Okay, so find all values of theta such that sine theta equals root 3 over 2. Theta is between 0 and 2 pi. What values of theta would make the statement true given the constraint? Okay, so find all values of theta that make that work. Okay, so first of all, sine's positive, right? So what quadrants am I going to be in? 1 and 2. And most likely it's probably going to look something like this, right? Where that's 1 and 1. And if that's 1 and 1, then this side would have to be root 3 over 2. Or you can take the unit circle and kind of go in the opposite direction, right? Once the opposite direction, you look at the coordinates and find the angle goes with it. So you could actually look at it like this way as well. Let me go to, I have a fillet unit circle somewhere here. Oh, I'll go back, sorry. Here we go. Okay, so where's the y coordinate root 3 over 2? At what angle?
460 and I square. So
you want to provide the angles where that can happen from 0 to 2 pi. I mean, of course I drew it, but you could just also look at the unit circle too. So that should happen at 60 degrees and 120 degrees. Or you can give the answer in radians, pi over 3 and 2 pi over 3. So those would be the values of theta that would make that statement true, given that constraint. Nothing else. Let's look at the next one. What values of theta would make secant theta equal to negative root 2? Now, if it helps, think of it as cosine theta equals negative 1 over root 2. Cosine's negative. Which quadrant am I in? Q what? Q2 and Q3. Right? Q2 and Q3. Okay. So it's going to probably look kind of like this. So that's 1 and 1. What's going to be the length of the legs? Yeah, root 2 over 2, root 2 over 2. That one's negative. And that's negative root 2 over 2. But it's cosine, right? Cosine is adjacent to our hypotenuse, so we don't look at the opposite sides. So what angles would you say that happens at? So 3 pi, you said 3 pi over 4? Yeah, thank you. Yeah, 3 pi over 4 and 5 pi over 4. Or you can give in the degrees. You can say 135 degrees or 225 degrees. That'll work also. Okay. I think that's as far as I want to get today, because if I do get into graphing, I'm really opening a can of worms. And to do it right, I'd rather just hit the ground running on Monday, saying, hey, Monday, we are doing, which means I'm probably not going to have time left to do homework with you guys. But if you look at this, is all in sine, cosine, and transformations. It's pretty meaty. I might have to, I don't know if I can get to all of it, but I'm gonna get to a lot of it on Monday for sure. Actually, hold on a sec. Did I go a little too far with that one? 8 through 14. Yeah, whatever. We'll get it done. So anyway, homework is gonna be the following. I'll tell you right now what you guys are gonna do. And I am gonna remove some problems as well. Give me one sec. I'm gonna tell you in a sec. Give me a sec.
No, it's not. Take care of everything. I'm licking up.
Really short, guys.
You're welcome. Let's start. So yeah, you guys are the employee next time. So you guys are used to but yeah, 23, 26 all, 28 Z, and 29. That's it. Yeah. That's it. I'll put them in assignment school, G.
As well. Yeah, cool, yeah.
Once I played really well. With the jacket. I sound yeah, I think about it. I swear to what's like. But last week, I was like, why is it US? Last time I played in here, that time. Always do a chance.